We're now joined by Dr. Andrew Gerrard, professor of physics and director of the Solar-Terrestrial Research Initiative at NJIT. Good to see you, Doctor.
Yeah, thank you. Likewise.
Let me also say NJIT is one of our longtime higher ed partners, helping us understand innovation, science, technology. By the way, what exactly is space weather? Because that's why you have us here. I'm reading saying, I don't get it. Help us.
Yeah, so every day we have different weather. Here you see rain, clouds, sun. It feels like we've been in rain for a while now, but the same thing happens outside of Earth's atmosphere. In space, the sun is putting out constant energy. It varies day to day to day, week to week, month, even on yearly cycles. And that variation impacts spacecraft and power grids and HF radio and GPS and everything else that is really communication oriented. What we're trying to do is do forecasts of that environment, just like we do forecasts for the daily weather.
What's the connection between space weather and New Jersey?
Yeah, we've actually got in New Jersey, one of the largest solar terrestrial space weather groups in the country. And it kind of just happened naturally, where we were developing an application-oriented program at NJIT, and there was this need to know how space weather, how the sun is impacting different technologies. So as we just kind of grew and developed this niche little region, we created this wonderful center, Center for Solar-Terrestrial Research at NJIT, that has really fostered a lot of the space weather initiatives that we see going on in the U.S. right now. Our senator has been very active in promoting these types of things.
Which senator?
Sorry, Senator Booker.
Cory Booker.
Yeah.
Question, connect space weather, Dr. Gerrard, back to our everyday lives. Give us a couple of concrete examples of how space weather impacts our lives so people can say, oh, that's space weather.
Yeah, so something that if you're ever using your GPS, for example, on your phone, there are times that you lose your location or you can't find track your kids' phones or something like that. It's not necessarily the phone itself or the cell provider. It can actually be, for example, a solar flare. We know that when the sun solar flare.
Go ahead.
These are radio emissions which basically drowned out GPS, and you lose that GPS lock for 2 or 3 seconds. Now, 2 or 3 seconds to you and I, when we can't find ourselves on a freeway or something, it's not that horrible. But if you're an aircraft coming in for landing, that's some very real consequences. If you're launching a rocket, you name it. GPS is really become a dominant means of tracking, identifying your position, and that information is crucial for a lot of different assets.
A great example: space weather and bird migration.
Yeah. We know that animals, as they migrate, they're much more sensitive, much more receptive to the background magnetic field. And when we have
Hold on one second. There's a lot of language that is familiar to you. What'd you call it again? Background what?
Yeah, the background normal magnetic field around the Earth, the one that we use for compasses and finding which way is north and getting.
Oh, that. Okay. All right.
Yeah. Yeah, it's
there,
but
go ahead.
But it's there, but it varies. We don't know that, but birds, animals, deer, they actually can track and sense that variation of the magnetic field, and this is what
they rely on it.
Migrating.
Do they rely on it, Doctor?
Yeah. This is how they tell which way is north and south. When that varies, so too do their flight patterns. For example, with carrier pigeons.
Wow. Climate change and space weather, please.
Yeah, so the source of much of the space weather is the sun itself. And as the sun is changing, there can be impacts certainly on the Earth's climate. Right now, we know that the sun doesn't vary too much in the visible portion of the spectrum or the radio. But in the ultraviolet, there's still some unanswered questions as to how much of our climate is impacted by that solar variation.
Andrew, how did you become fascinated with this area of science, technology?
Yeah, so as a student in college doing physics, I had a moment where I had to ask myself, okay, do we do this for the theory or do we do this for some part of application? And although I love the plasma physics, just the theory aspects, I needed to look myself in the mirror. So the application of that and the growing technologies of the 90s, 2000s with GPS, it just kind of worked naturally.
Important stuff. You've been listening to and watching Dr. Andrew Gerrard, professor of physics and director of Solar-Terrestrial research at NJIT, one of our higher ed partners. Andrew, thank you so much for joining us. We appreciate it.
Thank you much.
You guys stay with us. We'll be right back.
One-on-One with Steve Adubato has been a production of the Caucus Educational Corporation. Funding has been provided by Community Food Bank of New Jersey, New Jersey Sharing Network, the Turrell Fund, supporting Reimagine Childcare, Hackensack Meridian Health, the North Ward Center, NJ Best, New Jersey's 529 College Savings Plan, Johnson & Johnson, the Fidelco Group, and by Horizon Blue Cross Blue Shield of New Jersey. Promotional support provided by ROINJ and by Insider NJ.
At the Community Food Bank of New Jersey.
We are working.
Now more than ever.
To fill the emptiness caused by hunger.
We are the state's largest anti-hunger organization.
And together with our 800+ community partners,
we are committed to delivering food,
help,
and hope
to our hundreds and thousands of neighbors in need.